Okay, we only have 20 minutes, which is actually super short time. I usually do this in 40 minutes, which is a little longer. But before I start, I do want to tell you, when I came up here initially, I walked past the schedule, and there were these guys looking at the schedule, and they were looking at my talk, and they were like, he's just going to show his products. I'm shocked. How could you think of such a thing? This session, I'm actually not going to show any products at all. I'm sorry to disappoint you. I have a demo tomorrow at 2 o'clock. I'm going to show a lot of products, but this I'm really going to try to stay away. So, I'm CTO at SmartBear. SmartBear has an office here in Stockholm, so I work from here. I'm also the chairman of the OAI, Open API Initiative, so if you want to talk OAS, Swagger, that kind of stuff, happy to do that afterwards. I'm not going to spend more time talking about myself. Just really run through these slides now. So what is API virtualization is the big question. And I'm going to lead you there by talking about how people usually get there. So this is going to be very technical, very straight to the bat. So if you have any questions, you have to actually ask them afterwards. But please also don't hesitate to interrupt if it's really nagging you. So usually when you build APIs, there are a bunch of use cases where you might want to need a simulation or a stand-in for that actual API. And we like to grade that in the industry of building products for mocking or etc. We like to grade that in levels. So the lowest level being what we call stubbing and static mocking. This is something many of you are probably familiar with. You have an API and you just want to stub out some static response that you always get back all the time. You don't have any logic, and you just want to make sure that those responses are semantically correct, in line with kind of what you expect the API to return. And if you're lucky, you have metadata like OAS or Swagger definition or something else, or WSDL if you're in that world, that can help you to generate these kind of static mocks. And if you're unlucky, you have to craft them by hand, but that's usually what they do. And this is not uncommon. It's pretty useful. It's also pretty common to you have that in like API design tools. Like if you go to, I'm not supposed to mention any products here, but if you go to many online API design tools will allow you to automatically create static mocks of those APIs based on how you design them. Next step would be dynamic mocking or simulation. So here you go one step further. You want your mock not just to always return the same thing, but you want to actually have it be a little bit more intelligent. You want to return maybe different responses for different input. You know, if I put in this search query parameter, I get this search response. If I put in invalid input, I get an actual error response, et cetera, et cetera. You might even want to use scripting to define those responses, depending on the choice of tool, of course. And you could go in even further here to use like a data-driven approach. Pretty common that users have like a data set of thousands of rows of data, and they have a mock or a simulation of API, and they just want to run through that set of APIs. So every call I make to the search will return the next row in my database or whatever. This is a pretty common scenario if you want to do large-scale integration testing or load testing, et cetera, et cetera. You might also want to simulate state. So you might want to simulate the actual creation of a shopping cart, something put in the shopping cart, and then a checkout process. So you'd have to maintain some kind of state for your virtual or your simulated API. This can be helpful during testing and development. I'm going to get back to the scenarios later, and I'm just going to rush forward here. Next step is API virtualization. So we've done the static mocking, we've done dynamic mocking. So what else is there to add? Well, there's a bunch actually. One is more around runtime behavior simulation. You might want to simulate slow responses. You might want to simulate bandwidth, slow bandwidth. You might want to simulate stochastic errors. You might want to simulate anything that's not really related to the functionality of the API, but that is important to simulate because you need to know how your system behaves when that kind of behavior is exhibited by the actual API that you're virtualizing. You might also want to have some kind of runtime management for your virtualized APIs. So if I'm running a suite of integration tests and I've created virtual APIs for all my external dependencies like Braintree and Mixpanel or whatever, I want to as I start my tests, I want to get those virtualized APIs up and running. I want to make sure that my tests are actually using those and not the actual real APIs. And then after the test is done, I might want to collect results from those APIs, those virtual APIs, to see if they received the right requests and how many whatever requests they received, if you want to inspect that traffic. So there's a bunch of beyond just functionality use cases that are really helpful in a more large scale scenario. And speaking of scenarios, let's have a look at them. I'm really rushing here. So the first one is, I guess, maybe the most common one is more of a kind of bootstrapping your development of an API. So this is kind of what if you know, familiar with a contract-driven or design-first approach to APIs, you design your API in your favorite tool using your favorite spec format, and then you use that format to generate a virtualized or a static mock of that API. And that allows your clients to start building against that virtualization of the API. It allows your testers to start building tests against those APIs. Obviously, it's hard to build tests against a virtual API because it doesn't really return anything valuable, maybe. And it allows you to, if you're doing integration development with other services in your architecture or whatever, that virtualized API can really help you bootstrap that whole process. So instead of having to wait, or instead of having to, the server's down, or we're not done, or network's not working, you can just use that virtualized API. You might be able to run it locally on your machine while you're building your client in React or your mobile client or whatever you might be doing. It also, actually here, one common use case is what we've seen is this kind of rapid prototyping approach to API design. So people create their initial design using a tool, and then they create that static mock, and then they give it to testers, and then the testers start creating tests, and they're like, this doesn't make sense. You're not following our standards for naming, for example, or you're not following our standards for how resty we have to be, or whatever other kind of feedback they might have on the actual design of the API. So then designers go back, make those changes, regenerate the mock, et cetera, et cetera. So it actually helps not just downstream, but also kind of iterating just around the design of the API itself. Another common scenario is isolating components during dev and test. So if you have a component that you're testing that uses other external systems, you might want to simulate or virtualize these. A lot of examples here. I'll already mention, if you're using a database, you might want to virtualize the database. I know we're talking about APIs here, but it's also kind of API. If you're using external APIs, you're using, like I manage Mixpanel or Braintree or Stripe or whatever API, you might want to simulate how that behaves, because you don't want to pay for the usage that you're actually imposing on that external API, or you want to simulate errors, or you want to simulate some kind of response that they're usually not returning through the execution of your tests. You might have legacy systems. Sorry, I'm pointing at the wrong one. Legacy systems, you might have SOAP APIs, God forbid, or you might have just mainframes, that speak over a very TCP/IP or a socket-based protocol. All of those you might want to be simulating those just to provide your component with a kind of a black box environment where you know exactly when that component makes calls to the external components, what it'll get back to help you create both development and design, test designs. Flipping the switch here, if you're building an API and you're providing that for users, you might want to provide them with a sandbox. And you should provide them with a sandbox, especially if you want people to actually be able to play around with your API. This is a pretty common use case. I mean, if you go online, and I'll mention Braintree. I'm not paid by them, but I just happen to mention them a lot. They have a nice API sandbox where you can kind of play around with their API that obviously for them doesn't incur any costs related to infrastructure. It's totally isolated from a security point of view, and they don't really have to worry about what people do in there because they're not using the actual API. It's also for someone providing that sandbox, you can actually see, what are people doing with my sandboxed API? It kind of helps you get an understanding of what areas are they actually looking at maybe to use, to integrate with, and where might they have challenges or problems or issues. Oops. So others can use them to evaluate your APIs, integrate with them, and then also create integration tests, kind of back to the previous slide. And this doesn't obviously have to be for public APIs. It can be internal as well. If you have a complex microservices or just API-based infrastructure, this can be helpful there as well. We've actually had users creating simulations of hardware components. A major Swedish telco that provides switches used a tool instead of when a customer was looking at buying that switch or integrating it with their network infrastructure. We actually provided them with a simulation of that switch. So instead of having to send the entire switch out to the customer, they could just download the simulation of the switch, run it in their local environment, and then integrate with that before actually having to invest in the hardware itself. So there's a lot of valid and valuable use cases here. Performance testing is actually pretty common, and this kind of once again goes back to a little bit of the things I said earlier. If you're performance testing a component that uses other components, you don't necessarily want that load to propagate to all your external dependencies. You don't want to want to load your database. You don't want to load your other APIs, your databases, or again, Braintree, for example, or Mixpanel or anything else. Because once again, they might not be happy that you're doing it. Maybe you don't want to pay for that traffic. Maybe you want to be able to control kind of the response times you get back, the latency you get back, and maybe you want to control kind of how that behavior is, and which allows you to measure really how does this component that's being load tested behave based on how these behave or don't behave. Yeah, I'm not great at slides. But anyway, this is just to kind of illustrate a complex infrastructure where you have a lot of components depending on each other. How do you evolve them independently? If you have a microservices architecture with hundreds or tens, maybe more applicable, but hundreds or thousands of services, what if I want to migrate or evolve one of them to version 2 or version 3 or whatever? How do I do that without affecting external dependencies in development? Another great opportunity, basically going back to what I said earlier, you can virtualize its dependencies. You can configure them to behave just as you want, as you see them behaving in that use case once you deploy version 2. So it really helps you kind of, in isolation, evolve parts of a very distributed and disconnected architecture. And this doesn't have to be REST, obviously. It can be any protocol. It's more conceptually. So if we look across the API lifecycle, design, build, test, deploy, manage. I'm sure there are other versions of that. Well, we see that static mocking really provides value early on in the lifecycle during the design and build phase. Once you start testing, although I'm sure you all do this all at once, iteratively, dynamic mocking is more valuable because you want to be able to have a little bit more intelligence in your mocks. Then as you go into test and deployment, API virtualization can really be of great help to achieve your goals there with your APIs. Okay, rushing ahead. So how do you create APIs? Well, I've already mentioned one is creating a virtualized API, creating from an API definition. So if you're lucky to have a Swagger OAS, RAML, Blueprint, Whistlewobble, etc. definition, those usually contain schemas and metadata that allow you to generate responses, which are a great starting point. OAS has now OAS 3 has great support for examples, so you can easily have multiple examples in your definition which can be used to generate virtualized APIs. As I mentioned earlier, static mocking is often integrated in design tools, so it's something that you'll see in a lot of tools out there. And yeah, I've already talked about this, sorry. Another common way to do it is use captured traffic. So basically run Wireshark or collect log files or run your API traffic through a proxy where you can record your traffic and then export that to HAR files, and then use tooling that allows you to import that captured traffic. And then the server side of that traffic you can use to generate those virtualized or APIs. You can use the client of that part of the transactions to generate tests, for example. But since we're talking about virtualized APIs, so you use the server side. Obviously, or not obviously, but often you might want to post-process that collected data. You might want to change session cookies, or you might want to remove sensitive data. Pretty common that you might want to exchange usernames and passwords and other stuff that you don't want to actually be exposed by the virtual API. And tools that you use usually allow you to easily scrub that data or modify it, or maybe even make it a little bit more intelligent using scripts. You might also want to record non-functional aspects, response times, latency that you actually play back when you run your virtual APIs. And if you're using SSL, if you kind of, for example, recording traffic from a mobile app that uses SSL, which it should always do, to communicate with the server, you can do like a man-in-the-middle attack on your own API, of course, using SSL certificates to kind of still decrypt the traffic on the way. So that's definitely not a blocker. And then, as I mentioned, refine the recorded. Either you create your virtualized APIs from definitions or metadata, or you record them and then you can refine them with dedicated tooling. You might, as I said earlier, might want to add logic for request dispatching, add any kind of functionality that we've talked about earlier. You might need when you simulate your APIs. And usually do a demo here, but I'm going to do it tomorrow too and show you all this stuff. So please come and watch that. 5 minutes. Okay, so what are the considerations here when you're kind of looking at how do we work with static mocking, dynamic mocking, virtual API virtualization? One thing is it just you, or is it a whole team? Is it an enterprise? Do you want to share your virtual APIs across projects, across tests, across processes? How about the people who are actually building these virtualized APIs? Are they developers? Are they testers? Are they familiar with coding? Are they comfortable coding? Or would they have more like a point-and-click kind of tool to do that? Is there a CI integration? As I mentioned earlier, you might want to run your virtualized APIs, start and stop them as part of integration tests. How does that work with Jenkins or whatever tool you might be using? And how do you redirect traffic while you're running tests to your virtualized APIs and not to the actual real ones? The more enterprisey tooling usually has good support for all of this. Access control is another thing. What if I'm building a virtualized API that does expose some kind of sensitive data? Maybe I don't want my consultants to be able to consume that, but I do want our internal developers to be able to consume that virtual API. So how do I manage access control of it? And reporting and governance, which senior management usually likes, just to see kind of how is that virtual API being used and how are we using. And it's actually can be super helpful to see from a coverage point of view, if you have a virtualized API, are we actually using all of our the surface of that API in our tests, or are we just using a subset of it? Why aren't we using all of it? Do we have functionality in there that we're not using, or that we forgot, or that we could remove? Synchronous APIs, not going to talk about that. Do you need it? So if you're doing local development, basic component testing, do you need API virtualization? Probably not. If you want to provide sandbox environments, either internally or externally, you probably do, because of the non-functional aspects that are valuable to be able to simulate. If you want to have a collaborative evolution and testing of APIs with low number of external dependencies, maybe. Collaborative evolution, meaning that there's a lot of people involved in building your APIs and evolving them. Here you can probably get away with this dynamic mocking. But if you have a more high number of complex dependencies, especially once again, if you have both external dependencies, internal dependencies, legacy systems, more modern APIs, and you want to be able to simulate non-functional behavior, I think that was actually the last one. There you go. You definitely need API virtualization. Complex decision, yeah. Look and animation, yay. And I've never done this talk this fast. I'm sorry about that. I have 2 minutes left. Oh, I'll do the demo. No, I won't. I'll do that tomorrow because it takes more than 2 minutes. Does anyone here do API virtualization or mocking of APIs? Not many, or are you shy?
What do you mean by API virtualization? Having a virtual environment for...
Yeah, so exactly. So I guess I didn't get my point across. Low grades for me. Yeah, so if you go from exactly providing a virtual simulation of an API, not just the functional simulation of an API, but also the non-functional, meaning performance, maybe security-related aspects of an API, just whatever is not functional behavior, and having that well integrated in your process of building and testing and deploying APIs.
Thank you so much. I think we need
to stop. You don't
stop.
look convinced, but
okay. we can go into more details.
Happy to talk more about it later. Yeah. Okay, thanks.
Thank you.